Hi ladies and gentlemen, I hope everyone is doing well today. Today we are looking at ionization trends. So we start off with some information on separating charges. We have some metal spheres. This information is very similar to the information from one of the previous sections. We have to remember that the spheres in diagram C are closest together because they have the strongest attraction, +7 to -7 compared to +4 to -4, +3 to -3. So we use these relationships between the charge and the distance to answer the first few questions, 1 and 2. So when we come to question 3, we're comparing the attraction between nucleus and outer elements, outer electrons. So we can calculate charge attraction, same as we did last time. Charge attraction equals the number of protons minus the number of electrons shielding. That's question 3. Question 4. So question 4, now we're trying to think about if we were to remove an electron from an atom of fluorine or an atom of nitrogen. So to answer this question, you need to compare charge attraction. So remember that if the charge attraction is large, then you have a very small atom because there is lots of attraction between the nucleus and the outer electrons. So taking that into account, if we have a large charge attraction, do you think it's easier or harder to remove an electron? Remember how charge attraction affects the outer electrons. Larger charge attraction, you pull the electrons in closer together. So now using that information, you guys should pause the video and try to answer questions 1 through 5. So next we have some information on ionization energy. So I've highlighted a couple things. The first sentence, so the amount of energy it takes to completely remove an electron from an atom is called the ionization energy. So that's simply what ionization energy is, energy to remove an electron. The first ionization energy is the amount of energy to remove one electron. The second ionization energy is the amount of energy is needed to remove a second electron. And then on your vocab sheet, you have N ionization energy. So N, remember N is a variable, so it can be any number. So if N is 8, then it's the amount of energy it takes to remove the 8th electron. If N is 100, then it's the amount of energy it takes to remove 100 electrons. So remember, N can be any number. The next thing that I've highlighted is that noble gases have 8 electrons in their outer energy level. This makes them very stable, and then it also makes it so it takes a very high amount of energy to remove an electron. So that is extremely important. When you have 8 electrons, you are the most stable. So we start to see a trend. The closer you are to 8 electrons in your valence shell, the larger the ionization energy. And that's because we have a very large charge attraction, and we have a large charge attraction because we are very stable. So those principles can help you answer first few questions. First thing, we come to question 7. So question 7 is asking us to think about a trend. So we have to remember, as we go left to right in a row, the charge attraction increases. Now knowing that the charge attraction increases, think about how that affects removing electrons. 8 is a Bohr diagram, you can do that. 9. So 9, we're looking at the Bohr diagram of sodium. So it's asking us why is the second ionization energy so large? So you have to think about it. So if we remove this electron right here, how many electrons do we have left around the center one? Would having this many electrons around the second energy level, would that make it easy or hard to remove? Remember, you can calculate the charge attraction. So if you calculated the charge attraction for the first electron, it would be +1. The second one would be +8. Remember, if it has 8 electrons in the valence, it's very stable, very hard to remove electrons. So that's why we have a very high ionization energy. Question 10 uses the same principles as question 9, except this time we're in the third. So we've already removed 1 electron, we've already removed the second. Why is removing that third high, and what is that atom? So then lastly, we have some information on 2 magnets. So we have diagram D and diagram E. Obviously there is less distance in D than there is in E. So these will help you answer the first 2 questions. So then question 13. Would it be easier to remove an electron from nitrogen or phosphorus? So when you're thinking about these, again, it comes back down to charge attraction. So what you're going to have to do to solve 13 and 14 is calculate the charge attraction and then compare charge attractions to determine whether or not it's easier or harder to remove an electron from nitrogen or phosphorus. So that covers most of the packet ionization trends. So please work on all the questions. Bring any questions that you have to class, and we'll take it from there. Have a good one.